Status ranked was subbed as tier 1 and says end of line.
Okay, so, let's, all right, nothing is wrong here, let's be clear, it's just, frustrating. So, let me give you a summary of, where I am currently at. So I've, been working with Saki this morning, some more here, and we still don't really have a great idea, and the problem is that we had a fantastic idea last night that seems like it should have been it, but it wasn't. So yeah, so right here, let me move these probes out of the way. There's now a thing stuck on the back of the chassis, and let me see if I can do a thing here really quick. This would be really slick. This actually works. I'm gonna guess it won't, just because it hates me. Let's see. I've been trying to get it set up so that I can wirelessly stream this tablet, but because this thing is Wayland, that makes my life complicated, and now it is making my life complicated in a new way. Thank you. Tech Scope has an unconnected GPIB port. I mean, that's because it's the floater one. It's frankly more important that scope is VGA than it's GPIB.
And Starbucks subbed as tier 3 and says good afternoon. End of line. Nicholas subbed as Prime
you know what?
And says can the terminal order a Capacitor yet? End of line.
Stay hydrated, boy. Thank you for the tier 1 sub and for 5 months. Dave Starbucks, thank you for the tier 3 sub. Holy moly. And for 34 months, I forget what the hex is, but I'm moving along here. Nakalak, thank you for the Prime sub, also for 34 months. I appreciate that. One moment here, and I'll give you a closer view of what's going on in the back there, because it's pretty critical. I don't think it would have ever worked without it, but it still doesn't work. But it wouldn't have worked without it, that's for sure. All right, missed yesterday's stream because work called me in. Well, good news, you didn't actually miss anything. So, there's that. Okay. This is the back of the 6045 floppy or hard disk drive on the microNOVA cabinet. This is the input connector that goes to the backplane on the card. That is the daisy chain connector, and that's a terminator. on there. Now, the floppy drive had input from Backplane and then output to this, the hard drive, and then it had this. You apparently must have the terminator on the bus. So I have now relocated that to the back of the unit. So that's what this thing is down here. It has been moved to the computer itself. It seemed like, you know, hey, if the bus is unterminated, it probably won't work. Didn't actually change anything. So we've still been trying to figure out that. Yeah, let me show you what Usagi's talking about right now. So I'm gonna put the CPU card back in because just, you know, this is where we're at.
We have all been waiting for dot. End of line.
Neo Dragon 90, thank you for the 100 bits. I realized I lost the ESD strap. Let me figure out where I put that real quick. There it is, underneath the tablet top. Okay. Okay. Do you plan to build all of this play pong? No. Okay, there we go. Let me pop this back in. ESD is actually kind of important. I kind of regret we didn't take more ESD precautions when we were doing this live, because I forgot how badly this carpet generates ESD. I don't think that that's any kind of a cause or problems, but I want to be aware of it. And the whole chassis is grounded. I mean, it has to be actually plugged into the wall for it to be grounded, but I don't know. Anyway, yeah, so there's CPU card back in. Okay, I'm gonna go ahead and enable this. That is the oscilloscope that's right there. Okay, and I can even enable this for fun. Let's just, let's bring this over. Oh, it's BSP and BP1. Wait, was that what I was measuring, not Phil? Wait a minute. Did I get to Phil yet? What was the last thing I sent you? Oh, Phil was a previous one. Okay. Well, that's unfortunate. Because that, okay. Hold on. Where was the pinout? Okay, Phil. Okay, Phil's actually really easy to get to. Okay, we're just gonna hide the other one here. Okay, so Phil is gonna be the bottom one when I show this. So I have a female, you can't see anything. I have a unicorn over here that points its horn directly at the motherboard, and then signals just fly out of it directly into the oscilloscope. That's how this works. Okay. So it's gonna be Phil on the bottom here. Moderately confident it's a setting issue. They got a jumper wrong. Yeah, that's my suspicion as well here. Also, this morning I put a piece of shrink tubing on the key, because it's actually cutting up my fingers, turning this thing over and over again because it's really sharp. So, okay. Don't need this when everything's in the chassis. Okay. So, we are measuring Phil on the bottom. Let me make sure these don't fall off and touch anything. Okay. So, gonna start the system here. You'll notice Phil jumped up because it went high. So channel 2 there, high is 4.6 volts, low is 4.8 volts. So it's being held high here. I'm gonna go into run mode. Oh, hello. Wait a minute. Sandy, I really don't care. Just like the 2 dozen. Please just stop. But Black Simon and viewers, hello and welcome. Thank you for the raid. We have stuff going on here. That is Phil. Wait, what? What's going on? Now I'm confused. That's weird. Yeah, so let me explain what I'm going on to the Raiders here. This is a Data General microNOVA. This is a mini computer. The rest of it is right there, a big old rack of it. Got a giant hard drive thing and some dual 8-inch floppies. This is the core computer. I have a bunch of boards taken out of it because we're trying to diagnose an issue with it. This is the Dasher terminal that goes to this machine, and we're about to try to put it into console. Oh, okay. PL start error, and then it stayed high there. Okay, that Usagi. The memory is accessible in run, but not in PL start, although that was a failed PL start. So let me go back to reset, go to run. It's toggling. We did not get into the console. Okay, we got into the console, but now it's working. Oh my gosh, computers, man, I tell you, not even once. What's the graph? So the graph is an oscilloscope measurement of 2 signals on the backplane of the computer. Specifically, the bottom one is the memory lockout. That's kind of weird. So if I try to read through it, here, let me point this directly at the CRT since I don't have video capture for that and the oscilloscope at the same time. You're confused? Yeah. Yeah, me too. Let me double check. So, yeah, this is the one. Oh! Fill is the top. Okay, I got it off by 1. I have no idea what the red, what? Hold on. Okay, just take everything that I sent you today, throw it out the window. Okay, let's redo this. It's been too much of this recently. Okay, well, all right. The stream restart. Yeah, okay. So, hello and welcome to the stream. You're catching me after I just realized that I don't know how wires work and what colors are. So let's try this again. Okay, so this is a yellow wire. I'm gonna go plug it into the black wire back here, okay? And then I'm gonna plug the black wire into the correct spot. Okay, so the yellow wire, I'm gonna swap these around. So my unicorn horn back here that is magically pulling signals, it's really complicated, but I tried to do it in such a way that I wouldn't actually get like the possibility of shorting anything on the backplane. So I'm using a female jumper to extend it out, then jumper breadboard wires, and I got the wire colors backwards and just, ugh. Okay, fill is going to be on the bottom now. It's actually gonna be on the bottom. So let's try this one more time. Tell me I was first lost troubleshooting signal, that was bad, realized probably the wrong signal. Yeah, so it doesn't help here, okay? If you look at one of the photos of the backplane, like the really wide shot of the last one, all right? I've been trying to keep this in my mind the whole time. Actually, yeah, look at the photo you sent me of the power connector. They cut off the last 3 pins, so I've been trying to make sure I count only from the left side over because I will do it wrong if I try to go from the other side. So, okay, in theory, bottom trace is fill now. So, on to reset. Fill is high. Go to run. Fill is in fact toggling. Start. Fill is high. Didn't properly start. I have determined that I can, ooh, now that's interesting. Fill is still high. Okay, when it gets into the memory monitor, fill stays active there. That's super weird. Okay. But, you know, 304, let's see, 304 is 0. Let's try and set 304. to 1, and then we'll try and read 304. Hey, look, it's still 0. Okay. So here's one of our thoughts for how to proceed with this. And I'm
tier 1 and says 35 months up. The number just keeps getting higher. Also cool terminal. End of line.
Flare thank you for the 35 months of tier 1 sub there. I appreciate that. With only one memory card in, make sure you're at the right memory address for that specific card. So this is the low address card, so it should be this. All their memory addresses come back 0 for sure, yeah. But no, this is the low one.
AGREEN 4548 S of S prime for 4 months and says end of line.
I am not set up to be able to see all of this at once. Hold on. There we go. K Green, thank you for the Prime sub and for 18 months. I appreciate that. Okay. 1,000 read. And yeah, nothing. The way this thing works is so weird. So like, I think if we read, let's do 77777 read. Okay, that's another address there. So we can press the read button again, and we could just jump around to different points in memory because it always uses whatever the last value was that's printed. It's very strange. I want to try something. What? 401. Still not convinced DGIC-based memory cards are good. Maybe try one of the other two cards using ceramic IC-based memory. So if the DG cards were bad, you're thinking that they could hold down the bus and not allow the other cards to work? Because I've gone through all the possible decades with the other cards installed singularly, and it still didn't work. What was I? Not let the ground connector sneak back there. Oh, I was gonna do this. Night night. Pew. Okay, so I did a power fail right there. I actually unplugged it because I want to see if 77401 changes. You guys can't really read that, so I'm just curious here. I'm gonna plug this back in. I'm gonna turn the machine on. Run. Start. It actually started. It did not change. Okay, I think the last memory address is used for the power fail, and it'll write to that, even if it's the ROM somehow, I guess, I don't know, to do stuff. Okay, you want me to remove the DG card. Let's try that. I have a thought of what could potentially make it work, but I'm holding off on that for right now, because once I say it, it's all you guys are going to want me to do. Is this frustrating? Frustrating is what I kind of expected going into this, and why I delayed it for so long. So, yeah. Okay. Oh, almost. Keep trying to find a good spot over here where I can just jam the grounding strap. There just doesn't seem to be one. All right. Strangely periodic interference that seems to trigger on consistently. Oh, the not being able to go into the memory monitor? I have no idea. Okay, so this is one of the RAM cards that is... I mean, we don't really know if anything works. Frankly. Okay. I'm going to go back to your image because I don't remember if it was the gold card or the not gold card that you suspected of having the lower memory address, and it feels like it'd probably just be a good idea to put the one in we at least have a guess on. So give me a moment here. Okay. Boop. So the gold chip should be lower. Okay. Yeah, there is not a lot of information to go off of on this. Also, I'll call this out. The spare RAM card that seemed to die yesterday absolutely did die. So I confirmed that today one of the rails that I measured at 11K yesterday is now a dead short. So the card itself did die. It wasn't anything in the in that thing. At least it seems like. Okay. Oh, that's weird. That's new behavior. Yeah, Digital Light Sage Data General hung around a lot longer than I realized. There's a 386 desktop from them on eBay right now. I would buy it if it wasn't $600. I feel like I should make a log of which cards I get to boot individually or not. Because I don't know if I've ever had this one boot individually. And the way that Phil is behaving there is making me wonder. Now we just gotta make sense of the changes, yeah. History there. I'm gonna get rid of the measurements. We'll make it faster. Very different than with the other RAM card, yeah, but I'm also not getting this one to start. Oh, it did something different there. Oh. Okay, I got in. All right. That's different. So, in theory, I think this one was in the 40 range, but I'm just gonna do this. 11, 1, 2, 3, 1, 11, read, no, okay, 5, read, okay, and then 1, read, no, 40, yeah, that's my guess. So I'm just gonna go through them all just in case. No. Okay, so this is where it maybe should reside. And I didn't even get my hopes up. This is like, what's the point? The only thing his computer wants to do is make you sad. So, no. If that's true, Spongy, our diagnostic procedures just became very different. Not to say you're lying or anything, but if we miss that. Not about RAM. I don't know that it has onboard RAM. I mean, 4K of onboard RAM would be a lot. I assume it has a small amount because it can run the console monitor with it, but I don't know if that's like a fallback amount of RAM or something. The only way to test all address ranges is very complicated. We don't really want to do that right now. Okay, page 19. Hold on. Well, just cheat. Okay, page 19. Central processor, board capacity. So, I don't know that means that there is RAM on board. On the opposite page, block diagram. Onboard memory. Okay. CPU. So 606 chips. 607 on this. So maybe those are pretty close. Well, if it's memory local to the CPU card, I'm even less happy about how consistently it starts. All right. Yeah, pull the memory. Yeah, just entirely. Let's actually turn it off first, so I'd probably prefer that. So complicated. Dude, these are useless, man. I need one that's like 12 feet long. I don't know how people actually work with these things, the ESD straps. They just aren't long enough to do anything useful. Okay. Putting it on my ankle doesn't help. The cable is just as long then. Let's get the just CPU and serial card. Yeah. So you on the wiki page where I have the roadmap, Usagi, you can look at a high-resolution photo of the CPU card if you want to see how it's currently jumpered. We have not changed anything. Yeah, so Spongy, the problem with the page 27 jumpers is that they're not quite correct. Some of them don't even exist on my card. I like that people will use when someone's looking. Let me try and fix something on this really quick here, because it's bugging me. Okay. What exactly do we want to do? Is there a jumper for disabling RAM? Because that would be nice. W1, W2, CPU start address of onboard RAM, and they're all removed, so it should be the lowest position. Okay. So it should be the 0 stuff. Oh, Nextcloud, you're dumb. Okay, hold on. Set up trying to sync all the data general PDFs onto the tablet thing so I could just review them locally here. And then it turns out Nextcloud went, oh, wait, sorry, those are spooky. I don't want to download them even though you told me to, so now I'm going to have to force it to download them. It might even work. Okay, there we go. 15 and 20% blinder 3 years ago. That is unfortunate, Chloe. Okay, now it's grabbing him. I'm looking at the manual as well right now. Whoa, what's W8? I don't... Wait a minute. W8. That might be part of it. Hold on. There's 2 ROMs, Usagi. So One ROM is for the console debug. We could remove the serial card, and that would not be there. APL, I'm wondering if it is auto program load, because I was looking through the programmer manual, and it talks about having a bootstrap in a ROM, and that might be that, and it might have a bootstrap ROM for loading from a disk drive. Moved up, no, it's W8. But I don't remember seeing W8 on mine. Okay, I actually have the PDFs local now, so it's going to be a little easier to work with. Okay, so one moment. I'm going to try and cross-reference this information here really quick. Okay. W4 disables both APL and starting address. Okay. So it's page 29 or something for... No, that's memory boards. Oh, that's the 76 technical reference manual. We don't want that. We want new fancy stuff. Or do we? Wait, what date is my card? 77, 77. Wait a minute. 77. So we were looking at the technical reference manual for 77 and not 76. Maybe we want the 76. Well, the inconsistency in jumper settings could potentially explain some stuff. Keep trying to make this not super illegible here, but there's only so much I can do. I'm sorry, I really wanted to be able to video capture this, but I have no idea how, since it's portable, without just running OBS on it and straight up sending it. Okay, hold on. Where are jumpers? Programming. I don't care about programming. Tell me about jumpers. 4 dimensions. Left blank. Didn't talk about jumpers. Well, that's interesting. Programmable read-only memory boards. Weird. I don't think there are any of those in there. Fortunately, the second manual doesn't show jumper locations. Okay. Interesting. Okay, so we're kind of screwed in that regard, I guess. That's unfortunate. Dude, I hate Ocular so much. Why doesn't it just render everything all at once? Memory usage. Greedy. Loads and keeps everything in memory. Preload all pages. Go for it. Do it. Yes. Okay, I'm going to reload these. Maybe that'll fix that. Okay, so technical reference 77. Close one of these. Dude, I'm hitting the button. I see the button turning red. Okay. And then programmer reference. Okay. Oh, that's so much better. Ah, nope, failed on one there. All right. Unless it used more than 50% of the memory already? KDE, I see the button turning red. Why are you not closing it? Okay, in fairness, no, what's using more RAM? Wait, how am I using 5 gigs of RAM? And Ocular's only using a small amount of it. Applications. Sorry, I'm tangenting here, but Firefox is just unknown memory. Really? You know, fine, we'll just close Firefox, see what happens. Well, oh my gosh, computer. Sorry, let's get back on track. Okay, jumper locations. So W8 would be possibly this, or it's possibly W4. It's hard to say. Because on my board, there is only one jumper position right here in the location where the manual says there would be W4 and W8 if Ocular knew how to render pages. There we go. And it seems like there might have been a W9 or something up there, but I don't know. Maybe I'm barking up the wrong tree, but... The boring reading the manual stuff is what I try not to do on stream, but we're kind of running out of ideas here. W6 is inserted. Memory address, all 7s, shall contain the contents of jumper word register with the starting address of auto restart. Okay, W6 is in the middle of the connector. I think that one is set on mine, yeah. So that one, we read the value that sets. That was like 77,410. So jumper word, dude, Ocular, please. W5's inserted address, 1 lower. The device address of the... Ooh, wait a minute. W5 is inserted. Memory address shall contain the contents of jumper word register with the device address of the APL option. So if we have an APL, 77776 should show us the APL code if we jump to the address location that that's pointed to. Okay. Just for giggles, here's the scope. Fail. Let's try again. Fail. 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 Well, Phil certainly is interesting for trying to debug this. I don't know what Deck Talk did. I don't know. It didn't show up in the back end. I see the thing there. I have no idea why it didn't read. Literally zero clue at all. But thank you for the 100 bits, David. I don't know why it didn't read it. There you go. Just have it reread everything, whatever. Something died. I don't know what happened. It's not happy.
Deck Talk is now online.
There we go. Currently using 2 cards, yes. So it is CPU and async.
End of line. Mac up as prime and says, can the terminal order a Capacitor yet? End of line. NEOTRAGON 90SICHER 100. The Nova we have all been waiting for. End of line. Blair's fires up as tier 1 and says 35 months. The number just keeps getting higher. Also cool terminal. End of line. AGREEN 4548 up as prime for 4 months and says end of line. David Fenton says
we had successfully done this before.
End of line.
Ah, okay, there we go. Dude, that is super weird. Trying to bootstrap the system and failing, it's weird that sometimes it works. Okay, well, we got in. All right, so we're in. Let me do, hold on, give me a moment. I'm gonna consolidate like the 8 different Firefox windows I have open here. It's kind of ridiculous. Oh, I still have the remote connection to the server going. Let's close that. Okay. What was I going to look at? Oh, I was going to bring up the manual, but the manual's right here. Okay. No, I wasn't. I was going to bring up this and press this. I got to reload the page. One moment. Control. Okay, but that's wrong. Or do I need... No, I know what I need. I need this. Boom. Will it work or will it be garbage? Oh my gosh, it worked. Okay, there's the terminal. All right. Now you can actually see that. Okay. So, okay. Moment of something, I don't know. 1, 2, 3, 4, 6... read all zeros. Okay, so we do not have an APL. And 1, 2, 3, 4, 5, 6, 7, or just 5s. Okay, so there's the auto restart. What is auto restart? Producer, you can look on the Tech Tangents wiki, just look at recently changed, and you'll find the microNOVA page that has an image of what the CPU card looks like. The configuration has not been changed. And then you can cross-reference the manual, because it's awful. I don't know offhand, sorry. I'm gonna try and figure that out here. So... let's see, programmer's manual. I want this one. Okay. So W6 is installed, but what's the auto restart? Auto restart has to do with backup battery. So, yoink W6. So yeah, one thing we've learned is that not having the backup battery seems like it makes causes a lot of problems. But 77. So what is there? 44, 560. That doesn't seem like it's going to be an address. No. So we do 77400. That's probably an instruction. I think what happens when it detects power fail, stores an address in power on restoration, jumps the address, and resumes execution from there. That's my assumption as well. That's what I thought it would be. But 77400 is 2000. The next one is 44. Those are definitely instructions there, with them being off by 1. Okay. To write any memory, Maggie Heals, any memory at all. Yoink W60, anything changes? Yeah, I don't see any harm in that. So, to explain this better, for those of you who may not have been here for it. So, let's say we do this. I'm going to look at memory address 2. I should be able to write to memory address 2. I could go 1, and then I could hit carriage return, and that should put a value in there. Then I should be able to look at the memory address again, and I should see a 1 in that second block of values there. But I don't, because I'm not able to write to that memory. I don't know why. That's the problem. So, all right. I'm going to shut this down. I'm going to brighten this. And then we're going to pop out the CPU card and remove W. You know, I don't even have to actually remove it. It's just right there. I can reach that without having to yoink the card, and then the card edge connector can avoid 1 cycling. Didn't use pseudo cheese. So here's W6. It's all squiggly and weird looking. There we go. That's W6 removed. Flare Spire, to be frank, we don't know. Because there is not a lot of documentation here. Okay, so with W6 removed, next time we try to read 7777 or whatever it is, it should be 0? Maybe? So, all right. Physically pull down a chip and see if it shows up. Pull a bit down on, I assume, on a chip. So we can't do that without making a backplane extender. Because there's no way to get in there. Now the fun of trying to get it to actually start. Here, I'll let you see the scope instead while I do this, since that's more relevant. Okay, we're in. Okay. I don't think you can do that because the data and addresses are multiplex as well. Ah, okay. All right, so that was W6, so 1, 2, 3, 4, 5. Still has an address. Cool.
David Phantom says,
Scope CHER 100.
end of line.
David, thank you for the 100 bits. That's weird. Also, do you all prefer this? Would you rather noise correct or noise reduce so you don't have to hear the fans? It's good at call Usagi. I do shift new line? No. Nope, that one's still 0. My voice is chopped up, makes your voice stuttery. I'd say no. Okay. It's probably the attack and decay. I suspect that if I keep talking, that it works out better, but if the attack and decay are bad, then I'll remove it. This might be a little extreme for it to try and... I've read through the programming manual for the memory monitor. There are not a lot of commands. This seems like we pretty much have it down. Try to the base memory addresses. So, want me to go to 2, 1, 2, hold on, I screwed that up. 2, 1, 1, 1, 1, wait, 2. 2. Yeah. What do you mean very quiet? Oh, I did actually bump that. Whoops, my bad. There we go, fixed. Yeah, checked. Yeah, so we have a programming manual here. And somewhere in here it'll say it. Look, it's got Copilot. Whoa! I don't remember being this far down. Oh, power fail, auto restart. Okay, let me need to look through this for a little bit. Oh, thanks.
David Phantom says gonna go now. Hope this
Wait.
cheers you up, CHEER 1000. End of line.
David, thank you for the 1,000 bits. It does cheer me up a little. Thank you. But I don't even know how I just rotated the PDF pages. But I just did. Thanks a lot, Ocular. I just like... How? How is this software this bad? Okay, modifying a cell. This is the section I actually wanted here. So, once a cell has been opened, and to open a cell, basically we have the current cell open down there. The user may modify the cell by typing a new value the cell is contained. 1. Followed by a carriage return or a line feed. There's a... Well, that was technically new line. But 1 carriage return on that next one. Let's see. If the ocular could render text, okay, if the line feed is typed, the cell will be closed, and if the cell was a memory location, the next higher memory location will be open. If the cell was an internal register, it will be closed. The next higher number internal cell will be open. If no new value is typed preceding carriage return to line feed, the cell is closed without modification. New value may be specified by typing an octal number or an arithmetic expression made up of octal numbers separated by plus and minus signs. Leading zeros need not be typed. The expression will be evaluated to low order 16 bits. Result become the new value. The period character can be used to signify the address of the most recently opened memory location. So, yeah. Octal numbers, I don't know. So, yeah, we should be able to, and then read the value, and then it should be there. But it's not. And then we should be able to do, you know, like 1, 5 plus 2, and then carriage return, and that should be our thing. We can do 1, 5 plus, and use that as our address. Hey, look, we just did math. Okay, there we are. I just did that, Usagi. Yeah. Well, if audio stuttering now, I have no solution. Sorry. So, yeah. I'm gonna go further down the page, look for that auto restart stuff it was talking about. Okay, program loading. Hold on, let me look at this a little more. Okay, there are two ways in which an operator can initiate a program load sequence. If the microNOVA computer system contains either the console, debug, or handheld console, they can be used to initiate a program load sequence. If the system does not contain either of these devices, but the CPU board is equipped with the program load option, a program load sequence can be initiated with the PL start switch. That's the one that we keep hitting to get in the console ROM. Initiating a program load sequence in either of these ways deposits a 30-something word bootstrap loader into memory locations 2 through 37, places device code of the program load device in accumulator 0, and executes an I/O reset function. Now, the device code thing here, we can actually run this right now. So if we wanted to, we could do like 1001 here, and then if I pressed Shift L, it would attempt to load from device 1. It won't be able to, and the system is now locked up. We can't do anything, so I will have to reset the machine now. There we go. That's weird, it's on 37. But yeah, so 2, read, nothing. So that should have been able to load from a device, but we don't have a device connected. So, yeah, they did make ROM cards, yeah. I have known that for a whole of like 10 minutes. Okay, so to enter a loader program, the operator must first set up the device that is to be used and make its octal device code available to the program. Being used for the console debug options is done with the dev-l command. That was basically what I just showed you. Octal device code in the program should be placed in bits 10 through 15. Bit 0 indicates whether programmed I/O device. I have no idea what that means. But essentially, even if we had the drives connected, I'm not sure we would even know how to read this stuff. And based schematic, yes. Wesley, it seems like we get completely random locations. I don't know what to tell you. I have seen 37. I think I've seen 400. I've seen it drop at, I don't know, some really high up value. I don't know. Because we can just look from 2 to 37. Hold on. 2. And then just scroll on through here. Nope, nothing. So, yeah, there's nothing there. In theory, 100 should be a significant value for something. I don't remember what. It's on the wiki. Hold on. 100 is programmed I/O bootstrap loader start location. So 377 should be the NIOS instruction loop location for booting data from a channel device. I don't know. Have a cold, hungering night today? Hopefully you feel better. Man, no, this is, I'm gonna restore W6 since removing it did not change anything. And then for giggles, we'll check that memory address again, just in case. Maybe W6 was not in all the way or something, and I fix it. And then it boots, and all's right with the world. And then world peace happens, and everybody wins the lottery, and, you know, it's really great stuff that happens.
Jason 5, the Force Tube subbed as Tier 1 and says, end of line.
That jumper sucks, man. It's really bad. What progress have we achieved? None. There you go, you're all caught up. Cell is written? No, because there was no data in it. Alright, reset. Run. Go. I said go. Please go. Go. I love this part where I don't... This is... We found the maybe quit in the astrology program. This is the maybe start button. I don't remember if it has a jumper in 4. Again, you could look at that on the wiki, because there's a photo of the card. I think the answer is no. Okay, we're in. There you go, 704, because, you know, why should anything be consistent? I'm gonna crop this over and then make it slightly bigger. And just for giggles, nothing after, and nothing before. Your photo shows no jumper, which enables HHC or console debug. Okay, yep. So that's about what we would expect then. I mean, I don't know. I don't know what to tell you, our programmer. I don't know. I mean, is this the programmer one? Yeah, okay, hold on. Oh, wait, no, I can just go back to the wiki page. So, the frame pointer 6A, oh, that's weird. Let's try this. 0A, okay. So that's accumulator 0. And then that's accumulator 1, accumulator 2. So accumulator 2 might be the last point of execution. Accumulator 3, accumulator 4 is the program counter of the interrupted program. Accumulator, or address 5 is the stack pointer. Address 6 is the frame pointer. 70 up. W1, 2, and 3 are backwards for some reason. Place CPU RAM in that reason. Yeah, we can do that. Let me just, for giggles, go through these until 17 really quick. Ooh, those are interesting. 10 is address location in the first 256 words of main memory that can be used by the console debug option. Wait a minute here. Address of the most recent breakpoint. User instruction. Contents of memory no, these are kind of like undefined. They don't tell you in the manual, but we get to 17. Contents of memory location 77.5. I mean, wait, that one isn't even like accessible. What? Mistyped that, or the OCR was bad. Zasher hooked up bog standard RS-230. I'm thinking I'm 1K word increments, something might be in order. That is actually on my roadmap here. Serial interfacing, I want to do that, but it's not a DB25 port or a DE9. It is literally the exact same connector as an AT power connector. So I'm gonna have to make a serial cable first. So, very bad just now. I don't know what to tell you. I don't know. I don't know why it would be having problems and why no one else is having issues. I'm checking. The server does not claim to have dropped any frames, so I don't know. There is 20 milliamp current loop, but that's not what this is. Okay. Can you check address 70 and up? Okay. So 70, 1, 2, 3, read, nothing. We'll write, boom. 70, 1, 2, 3, read, can't change out. So a gray is a dropped frame from the office to the server. Dude. Just don't complain anymore and hope it passes. I kind of appreciate that, but if it's something I can fix, I should try. I don't know, man. Dogface, if you're watching, I think your 2070's dying. So yesterday when we started stream, there was a black bar flickering at the bottom of it, and I've tried to render videos on the server recently, and they get this weird line in the middle where it's inverted colors. I think I'm gonna have to go back to the 1070, or maybe I can fit the, so probably gonna have to go back to the 1070. Must be Linux. Okay. Usagi, what do you think about starting the really complicated potential debugging avenue? Because I feel like we're running out of ideas here. I don't know why the deck talk didn't work, but Jason, thank you for the tier 1 sub and for 3 months there, and for the 100 bits. I don't know what the deck talk's problem is. Maybe I'm dropping internet here. I don't know. I'm getting really kind of tired of just trying to fix the small little issues on the side while I'm trying to wrap my head around a giant one. Running low on ideas, like I think we're in the wrong address space. Like the RAM is only up to 32K, which means half addressable space is dedicated to something else. Maybe peripherals. No way to convince it to change spaces. Yeah. Drive the RAM card in another slot. No, we haven't tried cleaning the backplane either. But I don't think that's it. Maybe I should clean the backplane a little more aggressively. Yeah, maybe I should clean the backplane first. It's not going to be was interesting, actually. If it wants to pretend like it's at that address, why don't we put it at that address? We could change CPU address, RAM address. I don't know, man. Well, so Ben, let me go grab a light so we can actually see the backplane. Because last time I looked in it, I didn't have my light with me, so I didn't get a good view. But it still seemed pretty ooky. Because it's real far in there. Let me see. Oh, actually, that doesn't look too bad. I have my doubts it's a backplane now that I see it closer. Oh my gosh, each one of the connectors is screwed in individually. So there are 18 Phillips screws to attach the backplane PCB to the card cage. They wanted to make sure you could push on those connectors as hard as you want and not have it pop out. Good grief. I have no idea what the HHC is. Okay, so we want 1, 2, 3, which are right here. Dude, this door is so annoying, man. That and blood, oh, wait, no, that was the, I was gonna say, like, blood sacrifice, that's actually the VJ. Which still didn't work, because sometimes when I turn on the thing, it doesn't, have the error. Oh, no, you generally have the handheld console or the, console debug option. So, you wouldn't, yeah, I don't even know that you can have it run in the same, memory range. That's not how it works, Majenko. So Paul Guy, basically, there's a, it might even be this card edge connector. You plug in a thing there and you have basically a calculator that you just enter in hex values for. Think of that Motorola trainer we looked at the other day. Anyway, these are the jumpers, so I don't know, man. I don't really have like great jumpers for that. So wires. And since we don't have any other boards in there, it should be fine. Lots of stuttering. Okay. Back in a moment. All right. Back? Okay, good. Thank you. Okay, where are the shortest ones I got? That one's pretty short. That one's short, and that one is short. Okay. Let's not use this one. Not even sure. Is this door spring loaded? I swear it feels like it. That's real long. Can it not be one that's 1,000,000 miles long, please? prefer it not be the same color as another wire, but you know what, oh well. Why is it not a wireless test wire? Yeah. Okay. Yeah, those don't fit. Cool. Okay. Time to dive into the pool of jumper legs that I keep around. That one feels a little big, which, holy moly, that's not going to be good because that one seems small. .606 are 4K DRAM chips, so this does have 4K RAM. It should be accessible via the memory monitor. Also means we can, with just 2 cards, you'd still be able to have usable system bootstrap, run some stuff like BASIC. Okay. Not really confident with how well that's making contact, but I don't have a lot of choices here. So all right, that's one. Why am I constantly getting notifications? And you know what? I'm going to preemptively mute DZAC. Well-deserved burn on poor DZAC there. I mean, Spongy, every time we use the terminal, we are using the CPU through the serial card. The backplane is working. Additionally, the ROM for loading the debug console should be stored on the serial card. So it is loading data over the backplane too. Trying to find a good candidate for a thin leg to use. So what I'm using to make these jumpers are old resistor capacitor LED legs. That one will probably work. So when I cut them off cleanly, I save them so that I can use them to make jumpers like this. Got to run to get lunch back in a few? Okay. There. Okay. I don't remember what address range that should shove it up into, but we'll just basically check all of them. Okay. Yeah, Majenko, that's, again, why I didn't just, hop all on board of let's go work on data generals, because it's going to be easy. No, everything about it is awful. How many manuals we got? None. What kind of chips are they? We don't know. How does it work? Nobody knows. Should be 70,000? Okay. Thank you. All right. We weren't trying to cajole you into working on them because we thought it would be easy. Watch you suffer. Is it really suffering, or is it just getting bored because there's nothing to do? All right. Run. It immediately failed. That's almost new. Oh, this may not work at all now. Because we have no memory in the low range. Actually, what if the memory was being doubled up or something? Yeah, it's 70s digital Ice Age. No, this is not new. Hold on, here's the scope. I'm wondering... Yeah, Lady Ironborn, welcome to my nightmare. I was just trying to find a picture of the backplane of one of these this morning, and the only references to the microNOVA are the Computer History Museum and me. I have a thought. The thought is that this will never work right now, because we have no low memory. So I think I should put the other memory card back in. Oh wait, then it worked. Alright, just make a liar out of me. Got it, cool, okay. Alright, oh, 700, or 70,000, yeah, 70, 1, 2, 3, read, set, 70, 1, 2, 3, read, and it didn't work, just like always. No, Lady Ironborn, it's just carriage return, new line. I don't know what to tell you, Diego. It's just not working today. I'm guessing my internet at home is sucking and there's literally nothing I can do about it. So I'm just, I don't know what to tell y'all. I'm extremely enthusiastic about attempting that kind of troubleshooting method. I do get what you mean, but not this time. All right. I mean, I can't fix the deck talk issues with the script thing. I have no idea what's causing that. I'm going to restart it again, so enjoy hearing all of the messages be sent again. Although I'm going to interrupt that because I'm going to change my keyframe interval, so I'll be back in a second.
PRE 48 S as prime performance and says end of line. David Phantom says fail CHEER 100 end of line. David Phantom says
Scope CHEER 100.
Okay.
End of line. David Phantom says gonna go.
No idea how that's going to end up working out.
Up CHEER 1000 end of line. Jason 5 the 4 Stooge subbed as tier 1 and says end of line. Jason 5 THE4 S2 says CHEER 100 blow up car.
Okay. Ben, that's why you grabbed the tip with pliers. Okay. Well, I'm going to revert the jumper change because that didn't do anything. There are other options, Spongy, to pursue still, though. And I don't necessarily have to have one. When I design it, though, it's going to be complicated. Okay. Removing jumpers. That's what I'm doing. Ah, that's cool, Majenko. That is not something I'm ever going to look at on stream, though. The last thing I need is people trying to tell me you should make it in an FPGA. So, never happening. Okay. This will actually boot. Nope. I can demonstrate that. This is nothing wrong with the switch. I have tested the switch.
BLUCKYPOP77SICHER 100. You should make it in FGPA. And a line.
I don't know how that happened, but Lucky Bob, thank you for the 100 bits. There we go. Okay. So, yeah, we're at 704. We can do plus, let's say, 10 address. And if we do period plus 10, now it'll be 20. There we go. So, yeah, that's how that works. Yeah. Yeah, you got it later, Aaronborn. Okay. So, yep. Okay, hit a Galaxy S, yeah. Alright.
Koraku says CHER 100 is my voice lower. I haven't been upping sulfur hexafluoride honest. And a line.
Chloe, thank you for the 100 bits.
Sleepy Developer says CHER 100 deck talk is fine. Does this smell purple to you? And a line.
Sleepy, thank you for the 100 bits. Well, I am unsure where to proceed here. I have only one idea. And it's complicated. So that should plus or minus signs, types of first character, new value, the value, type of expression, to be added to the constants. So Lady Ironborn, the real crux of it is that any number right here, I mean not one that big, that you then just push carriage return or new line on here should be put into the address you're at. So if we look back at 20, we should see something that's not 0 there. And we know that that's how that works because according to the manual, the ROM that is the console here exists at 77,400, and we can see this ROM. So we can go through this, we can see all kinds of addresses and data as tuples here, so we know that that's how that works. So when we go to, say, address 2, which is where, if this was, say, an MSI 8080, we would have all the toggle switches here. This is where we would start toggling in our code. We cannot modify this at all, and we have no idea why. That's the problem. We know what the correct commands are to do this, but we don't know. Hardware debugger attached to the bus. I mean, what are you going to debug? Here is an oscilloscope attached to the bus. The bottom line is the memory write enable, which, I mean, it's doing all sorts of crazy stuff. Is it the correct stuff? I don't know. We don't have any timing diagrams. We don't know what it's supposed to be doing. Check the voltage rails RAM uses. Need 14 plus or minus 1 VDD. So the power connector in the back yesterday, and I checked them again this morning. I'm not looking at the IC document. It doesn't matter. I'm not going to gain anything from that. You have timing diagrams for the CPU, but I don't know, man. Wesley, we can't get to the memory chips. They're under the card cage cover. I would need to design and order a backplane extender. The signal right there is the write enable line on the bus. Additionally, currently we're only booted from the CPU card, which has 2 or 4K, maybe I think it's 4K, of memory on board. So it probably wouldn't even need the bus. It should just all be there. So should be some technicians still alive who know about this stuff. I don't think you're understanding TechRW. Assume this is from 1975, okay? Let's say you were 20 in 1975. You are now 70. No, there are not a lot of archived manuals for Data General. Those two, look at me now. That's if you're 20. The kind of person who's doing this kind of stuff, 20 is a little bit of a stretch. No, I did not. Changing the memory address on the CPU card fixed nothing. Hard programmer, it really didn't matter. I think we go for the more complicated route. I know, Majenko, I am not looking at that document today. I don't care. I'm not. It's not happening. All right, yeah. I think I'm going that way. Talk to people who worked on some of the machines I regularly work with on the common failures back then. Very different from the common failures you see today. Yeah, that's the other thing. Because if you go back and look at the service note, like, oh, I tried to do this, so I replaced the whole card. Like the people who did the maintenance on these machines, they weren't sitting there like probing chips. They went, no, if I put this in, does it work? So what we're doing from that We would need the people who designed the hardware, because they understand how it actually works. They didn't understand how to, you know, just swap out a board. Uptime was paramount. Yeah. Yeah. There is one option that we have not yet pursued that is going to be complicated to pursue, that we're not going to get done today. That might just be the best option. The other fun thing about this is that if this shows any signs of life, you guys are going to hate me. You're going to hate me so much. Yeah, terminal's doing pretty well. These are not the drives I want to use, but they're gonna have to do for now. There is a manual for the memory monitor, but it tells us nothing. There are no schematics. At least not that I'm aware of. Because again, would there be schematics? You have a maintenance contract for this. Someone comes around and they just swap out the boards. I think, Spongy, that's in that IC dock. What on earth is this? Oh, thermal camera. Okay, that's fine. I can go. So, that is possibly the solution to Usagi, but we also have the intended configuration we can try. Okay. Hello and welcome to the next video in the Data General again restoration series, let's call it, because I am trying to get my micro working pretty much up and running when Usagi Electric was down here, which was an absolute blast. That was just a fantastic, fun, and productive day. But we ran into a bit of a hurdle when it came to the microNOVA itself, which we did get up and running, but we were never able to modify memory. And I have been working on trying to figure out why the memory wasn't working. We read through the manual, we figured out that the bus needs to be terminated. That seemed like a pretty good cause. We terminated the bus, that's not it. We've looked at different jumper configs, software mappings, and all sorts of things, and nothing seems to be working. We cannot use the console debug menu to modify any contents of memory, which should be possible. That's how you would load a program into the machine if you were operating it through the front panel. However, this machine was wrong. There's a whole cabinet over there that has drives in it. And it would be really weird and annoying if you had a whole computer system with drives that included a boot floppy and you had to walk over to the machine and manually type in a bootstrap loader. So my suspicion is that in order to get this machine to actually boot and do something that is actually computational and modify memory, the floppy drives to be. So today, we're going to start the restoration of the dual 8-inch floppy drives for the microNOVA. There we go. Now you're caught up. GoTech will never happen because it emulates the not the drive mechanism. The MFM emulator would probably be able to emulate it than the GoTech. Okay. Got like 40% of that? Why am I even streaming then? Mentioning the CPU has memory on it, that it is even accessible in the memory monitor. Yeah, that's possible. What I might do actually is at the end of the video from the stream, I might open or include that in there. So. Okay. Here's the thing. Do you guys want me to just stop the stream on the server and restart it and hope that that fixes it? Because I really know other things that I can do than that. You want me to try that to try and fix the stuttering? It's not the Office home link. It's not. It's behaving differently than it did yesterday, right? Because nothing has changed. Well, I have one potential idea. Let me try something. See if I. Lots of gray screens dropped frames of audio. Okay. I mean, but it looks like not. Yeah, if it is office to home, there's nothing I can do. At this point, I'm going to do it just to eliminate so that people can stop complaining, because I'm very tired of it. Like, I need people to complain so that I know there's something wrong. It's just super annoying, just in general. So, all right, I'm stopping the stream in a moment and restarting it. Okay. That is, you know what, I didn't actually restart OBS. I should have probably done that, but oh well, I don't care. All right, there you go. That's as good as it's getting. I'm super happy we didn't have these problems with upstream Usagi, because this is so annoying. I don't know how it was so good. Yeah, I know there were issues, but it's not that big of a, it's not as big of a problem as this. You don't actually need the drives come out, you just need the logic from the controller initially. True, but I want to see if it tries to, you know, seek the heads or access the drives to boot or something, because I think that could be an indication of it trying to do something. But, so I'd unplug the physical power to the drive itself, refresh the caps and send it and see what happens. Yeah. I just need to fly out and get some send it energy in the room. That'll get it going. Yeah. All right, let me get the trash can out of here because that looks weird. Should probably get the blanket and the Aladdin out of here too. You know, why not just move the whole thing? And pop this back up there. Soggy, question. How interested would you be in some kind of cover that goes inside of a drive like this? Because it's really driving me nuts that they're so dust sensitive and that they're just open to the air. And I feel like something needs to exist for fixing that. It's like they're super dust and air sensitive, and then it's like, oh yeah, just, you know, it's open. Don't worry about it. Like, it feels like the top should be sealed, and I'm thinking I might design something for that. Put the disc in, take the cover of the pack, place it on top of the disc. Yeah, but it doesn't, like, really well seal it, though. So, we do it. All right, here, put it there. Close that down, and then you put this here. Yeah, I feel like there should be something else in there. I mean, I see how it works. There's going to be a thing that comes over that locks this down. I don't know. It's so open. Like, there's a whole HEPA air filter in there. It's meant to be, like, crazy, you know, clean, but then just air leaks through this. Like, it just doesn't seem right. Things are positive pressure. That's why you got to let it purge. Okay. Well, if the air comes out through that, then all right. You're probably not supposed to leave it open like this forever then. HEPA fills up with a whole lot of positive pressure to purge all the dust out once you spin it up. Okay. Well, I'm going to keep this on here still then. For now. Since the computer's not in there anymore. Unfortunately, it was open like that for a while. I didn't think about that before. Yeah. All right, that was a good test lift. Because this next part, not gonna be fun. Gonna make sure the cables and I are gonna have too much of a disagreement here. expecting one of these to be just completely loose as well. But it's not. Why? Oh, wait, no, it shouldn't be. Never mind. Okay. That's good. All right. It's already been crashed. You can't hurt it anymore at this point. I mean, I'd rather not crash it again. As a story about data center removal work with a fleet of disk packs sometimes nearly cause fires of dust landing between the heads of the ladder. All right. Let me chuck this foam out of here, and then let's continue. All right, so this is the cabinet for the microNOVA, and specifically what I'm after here are these. We have two 8-inch floppy drives here, and the one piece of software that I think I have that's maybe good is meant to run on these. And that's why I think that they might be critical to the boot up initialization process for the microNOVA. Now, this is just a hunch. I don't really have a strong indication that this will solve the problem, but kind of running out of ideas for other things to look at. So getting these out and getting the whole drive and its power supply and logic system up and running again is a troubleshooting step, basically just to confirm that the machine itself is working. So let's get these out and start to bring this unit back up to life. This is a Data General 6030 floppy disk set as well, I should mention. There are, I don't know if other significant revisions, but some of the ones of these that I've seen online have dial switches here for code addresses. One here for this hard drive. I don't know how those are set on these, so that might add a complication to this, but I'm hoping that we'll be able to figure that out once we get it open and look everything over. For now though, I have to get it out, which is not fun. It doesn't retain in the rails, and it's heavy. It's not heavy enough to warrant using the carry cart, but not light. There we go. The floppy drive unit for the microNOVA. First thing I want to look at here is, no, I can't easily remove the drive. The Data General stuff has this like really bad habit of having the door be way bigger than the actual unit itself. So it's scratching on the table and catching, and I'm gonna have to put something under it to make that not a problem. Okay. All right. Oh, this is... Oh, man. Oh, it's a 6039, okay. Now I know. I still need something to go under it. Let me figure that out really quick. I think I have some denser foam over here. I just don't know if any is big enough to do anything meaningful. I kind of like these. Yeah. Let's try these parts. There we go. All right, now the first course of action here is going to be disconnecting the two data cables. So as I mentioned, the terminator pack could go on or inside this drive actually, and when we have this finally set up, that's how it'll work. But for now, these are the daisy chain cables that go to the backplane and then to the platter hard drive. So we need to get these out. Everything is already marked inside, or at least it should be from when I initially moved these machines. Where's my screwdriver? Supposed to be in the screwdriver bin, but of course it isn't, because why would anything be where it is? Oh, you know what? It's over here because I removed the hard drive cover. All right, where was I? Yeah, so I have been in this machine all day, and now realizing it's time to start documenting part placement. So we're gonna have some stuff to look at. I didn't steal shorthand, I promise. DG F L P. Okay. And these did come off when I wrote them on here, so lid. Oh, it's really hard to write at an angle. All right, with that, the front lifts up. And it slides forward and away. Oh, the pieces of tape are off. Okay. That's fine. We can remark it. So we have two connectors here. I don't know if they're actually directly connected or not. I feel like I checked this and they were previously, but this would be the input and this would be the output. And we know that this is the output because it has this extra piece of, it looks like FR2 on here. That acts as a shield for the terminator that can be plugged into here. But what I'm going to first do is just get the cables secured and photographed for how they go in here. That way I can put it back and know exactly what's going on. Lots of pictures. Just document everything out like crazy. Don't want to forget or mix up anything. All right, then this can just slide out the back. And that is where the cables are put into the system. Make sure, get them through here safely. There we go. That's freed. I'm not as worried about the power cable. It has a pretty nice grommet bushing bulkhead thing, so it'll be okay. But the rest of this stuff is where it's going to get complicated. Oh my gosh, those floppy drives. Oh, and while we're back here, I'll call it, this is actually a Model 6039, so that could explain the lack of ID switch dials. Okay, so there are a couple of things that are worth calling out here. One is the just insanely massive PCB here. This goes from this point all the way up to the edge of the machine. It has the front panel indicator lights, has all of the logic ICs. It controls both floppy drive mechanisms here. It is crazy. This thing is enormous. I think we may never have to remove this though, because we have a panel right here, and that seems to contain all of the capacitors for the power supply. So I'm hoping we could just remove a handful of screws here, have this pull out, and then we can work on that stuff. We will go ahead and remove all of the connectors from the floppy drives, and I may want to get them out to look at that, because I had one of the connectors on one of the Cume track drives for my S100 stuff, so I might want to look at those a little closer when I do that. But I think we might be able to work on everything pretty much back here, because this looks like the whole DC power supply system, so it's not going to be too complicated. That's the Sharpie. I don't want to use that. Let's see. Let me just grab the last paper towel I threw away. All right. Might I ask, how'd you acquire this system? It's a very stupid story. I'll phrase it this way. Basically, I got them off Craigslist. Cap. I was going to say plate, but caps. You know what? Just caps. Got to head out for work. Thanks for streaming. Good luck with floppies. All right. Good luck with what you're working on. My stuff's going to be really slow and tedious from here. Oh. No, this doesn't do squat. This is basically going to let me probe stuff. It's not going to let me do anything else. Yeah, all it does is give you access to the board. I was kind of hoping the caps were mounted to that. Okay. That's not that useful. Yeah, I'm going to keep a paper towel over here for wiping this, I guess. I think RF programmer, I'm not really 100% sure what they did. All right, so what I can see from here is one screw head on this side, but then there's another screw over here. That's strange. I don't think it's going to be one screw that holds this in, but that's part of a TO2 heatsink, so I don't know. Oh, I can see around on the other side where some giant caps are. There's a structure that might be mounted. I don't know. Maybe I should look at the... Oh, wait a minute. I'm thinking too small. This is a whole plate that removes and possibly slides out. Why is it missing so many screws? There we kind of go. All right, I got some cable wrangling to do. So this needs to be unplugged. Let me get a photo of that. I keep seeing the lead screw coming out of the back of the head stepper motor thing for one of the drives, and I keep thinking it's a giant spring, and I keep thinking, why is there a giant spring in the floppy drive? Oh, that's zip tied in too. Cool. All right, that's one. Down here, connector that goes to the 120 volt motors for spinning the discs in the drives. Oh, I don't know how this one releases. Cool. Maybe I'll be able to when it's loose or coming out more. I don't know. This cable has sagged down, or maybe it even hasn't. I think it might just be poorly designed. Or I can remove this bolt and then move it up and out of the way. Actually, nut here. Let me try that really quick. So I'd rather not cut this. This is a permanent zip tie mount thing. It's not a it's not a cut and, you know, move on with your life one. Markers on the connection for direction. Normally I would. This one's keyed, and if I manage to plug that in backwards, I will have torn it to bits and pieces because it is so formed in one direction. So I'm not too concerned about that one. Okay. Okay, I am going to have to cut this slightly because it's sticking up too much to be able to get the socket over it. But I don't want to ruin the retention. Did that just work? No way. Oh my gosh, it did. Crazy. Oh, there's a washer. All right, now those cables can move up and out of the way. But we're not done yet because I still need to be able to unplug the one that goes to the motors. So that connector right there is the next problem. I just don't see retention tabs on it unless they're on the sides. And there's a little groove right there, but if that's it, oh my gosh, this is mean. One thing I can be happy about with these computers is they actually smell kind of good. I don't know how to describe it, but they don't smell unpleasant. I don't mind the smell that they have. It's weird. Do you have any further thoughts on trying to image that hard sector boot disk? Nope. I have not had the opportunity to look into how to image that. If anyone wants to look up a procedure for the Grease Weasel or CryoFlux for imaging a hard sector boot disk, or see if anyone has successfully done that and documented the process, I am all ears and eager to hear about it. I think the CryoFlux might be the more likely one, but I'm not sure. Dude, this thing sucks. I think Usagi had to bounce to go do his own stuff. I really don't want to remove the transformer just to do this. I might have to. Oh, I forget how little you can see through the front. Some support, all right. You know, I might be able to remove these. I can, I don't like it. Might be my only option. There's another one on the other side. Don't know if it's the same size. I'm thinking not. It looks smaller. Doesn't matter. I can't get to it anyway. CryoFlux say it supports hard sectors since 2017. All right. And I might try that. Hard sectoring is not a hardware feature. It would be a software feature to determine it. At least for this kind of hard sectoring. It's possible there are other kinds, which makes this, you know, even more fun. Maybe we just, you know, disrespect the little locking tabs. We just, you know, whatever. Yank it off. Screw you, locking tab, just go away. Grar. It says, nope, I'm here to stay. Sorry, not very talkative here. This is just really intensive. Come on. All right. Taking this a different route. Platypus with cheese, no. The extra index sent, the extra holes for the sectoring are located in the same ring as the index 0 sensor. So when trying to read the disk, the hardware constantly is reading sector 0 over and over again, and it errors out all software. So it's a much more complicated problem. Okay, whole cable's loose all the way across. All right, there is this big giant, you can't see anything. Yeah, that was a pain to fight, and I'm not even done yet. There's this giant harness of cables that goes across here for connecting to the DC power and AC power, and I haven't been able to disconnect the AC power cable yet, but I think I can get this unit out of here at least. Yeah, there we go. The problem is the AC power connector is this, and the tabs to release this connector are on the sides next to the giant heavy transformer and the bent piece of metal. So I have no idea how they expect you to actually be able to disconnect that, because you can't get to the retention tabs. So I'm trying to get tweezers into here to press on the tab as I get like this thing and press on it from the side, and I am just having no luck getting this thing out here. So I still need to fight this for a little bit more before I can continue, because I don't want power going through there for when I eventually power this thing up to check the DC rails. So I still need to figure that out. Use a dip puller. I don't think I can apply enough pressure with that. Additionally, mine probably just isn't going to work out right. Also, this plastic shield is in the way for that. Yeah, that's just not going to work. Maybe it isn't meant to be removed. I bet a service tech would wholesale replace this power supply, so I bet it is meant to be removed. I have a couple of options here, though. Unfortunately, somebody lost all of my ratchet drive to 1/4-inch wrench adapters. I'm not going to name names, but I'm pretty sure they're in the room with me right now. So I can't easily drive straight down here, and it's kind of annoying. I wonder if it could be in the chuck of one of these. No, but there is a... There's that. That's interesting. Well, it can be unscrewed, but that's not easy either. Additionally, this socket's too big, and that's the smallest one. No, I have some other smaller ones. Maybe. All right, well, Vorpal Sword, I'm not going to get to that today, most likely, so I'll just have to look into it later, but good to know that it's potentially there. That is 8mm. Okay. This is 5/16. No. This is 9:30 seconds. You know, that's a dumb enough number. I would have believed it. Although, don't I have the... weird Model M driver? That might be the right size. It's like 7:30 seconds. I think it's in here. Oh, here's this thing. Whoa, what if this is the right size? Nope. Ah, the Model M driver. Oh no, that's way, way too small. No. Oh my gosh, I knew it. It was 7:30 seconds. I've worked on way too many Model M's. Yep, offhand too. There. We are poor, battered people. By yeah, I don't think I have any other socket drivers in here, so that's not worth looking through. Well, that goes in. That's not helpful. Eugene, thank you for the 100 bits. Sorry the deck talk didn't read it. I literally do not know why. It just keeps stopping after a while, and I don't know. It's not audio issues. I have no idea why. There's some weird network going on that we have never experienced before, and I just don't have a solution. Dude, holy moly. Oh my gosh, I got it! Yes! Oh, I never want to plug it in again. Whew. Okay. That was terrible. Okay. Oh my gosh. All right. Remove the tabs. I have no idea what you mean. And this is probably going to be a lot lighter because that's a big old transformer right there. Oh, that's a cakewalk. The tabs you were fighting. Oh, I like the way you think. I don't know that I can get to them, and I may have also removed them with the screwdriver by flattening them. Okay. All right, I finally got that connector off and we have just the power supply here. So let's look over what we have. We have one gargantuan transformer here. Over here we have fingerus chopperus. And then we have 4 big capacitors here. So this one is a 24,000 microfarad 40 volt cap. That one's gonna be fun to reform. That one is a, what brand is that? It might be Nichicon. I don't know. It's difficult to see because this is flat on the bottom, so I'm not sure. Then we have 2 probably Sprague Compulytics. Can't see what they are without removing them, but there's 2 different lengths. And then we have one of the weird caps here. I'm not 100% sure how to handle these. This is rated for something VAC, so we'll have to take a look at that. I think I should probably get some documentation photos here and then start removing these massive capacitors so that we can reform them. All right. There is no good way of determining polarity because the sides are all just blank. So I think I'm gonna do this. How high did that condenser tester go in voltage? Yeah, I might need that for this. We'll see. If this is above 50, I'll be looking at that. Like Sharpie marking. I said it in the stream and clarify it. I do not like leaving permanent marks on the device with something like a Sharpie or something. So I'm going to mark these with tape to indicate where they go. So, and then I can just use the tape to put it back. I should wipe them off a little first though, because holy moly, the dust. I mean, yeah, that one's definitely AC since it's connected directly to AC there. So that one probably won't matter too much how I connect it. Interesting. Okay, this one won't matter, but I'll just do it anyway. Okay. Big cap. Tall cap. A C. That was awful. A C cap. And short cap. All right, I've got the polarities marked and photoed on here, so we're ready to go ahead and remove all of them. Although this first one I say here is connected literally directly to the transformer, so I don't think polarity is going to matter too much on it. So, yeah. The other ones, though, they're definitely going to be DC caps. Definitely going to want to make sure that one's fully discharged. It's got to rub all the way across the bottom to get it out. And then that one's got lugs on it. I don't think I've had a cap with lugs. So it's just got nuts holding it on. Just let me use my wrench to remove a capacitor. Okay. Oh, and there was a ground strap on that one. Okay, I want to make sure I keep that in place. Oh my gosh, I was putting so much pressure on the board, the whole thing leaned forward. And there we are. Wow, that's actually kind of light. Another Sangamo. So, all right. There we are. That's all of the main large capacitors removed. Not even sure there are any small ones on there. Maybe the little tiny ones. But yeah, these 4 here are the main ones that we're going to be worried about. Yeah, we're not reforming this one. 660 volts. Jeez. Test. Yeah, that is that's a fun part there. I think we might be able to do it a significant portion though. The cap mapping is more related to replacing caps. Ideally, these don't need to be replaced. I'm not looking at that quite yet. Oh, we can reform an AC cap. I'm not going to be thrilled with the process, but it's going to be possible. Okay, so this is 20 volt, cakewalk, only 12,000 microfarads, 20 volt, 6,300 microfarads. Probably don't even need to do that one, but we're going to anyway. All right. Oil, so no reforming. Maybe? I don't know. You use an AC voltage, Vorpal Sword. I want my trash can back. Okay, get the tape out of here. Let's get some stuff put away. I mixed parts. Cool. Well, I don't know. Great. It's likely fine unless it's catastrophically failed. Isn't that what everyone says about everything, though? They just want me to plug it all into the wall, watch it blow up. Just need a little moment here of preparation because I was not set up for cap reforming today. Kind of had a feeling that it might come to it, so I was like mentally ready, but don't have everything connected in place for it currently. Oh, you know, that might not be helping the deck talk. Having another serial device plugged in. Okay. Fatty Mo, I gotta be honest, I don't have a strong familiarity with oil paper caps, so you might be right. There is still something we can do even if we don't actually do anything to it, though. So we're going to continue down this path. Want to be the new Electro Boom now with more boom. I don't think anything I've ever done has actually come close to that. So I'm going to go no. All right. Now I get the fun of fixing my capacitor probes, or capacitor, resistor holding probes here. Where did I put the resistor? Okay, perfect. Still in the jaws. It's a nice looking terminal. It might be the prettiest one ever made. I say I feel it is. I didn't want to blow up the tandem floppy drives. Okay. Let me bring up my reference image for cap reforming here. Okay. So power supply negative goes to multimeter negative. That's not right. What? Both go negative. Well, why isn't this negative? Hold on. Positive. Oh, because no, now I'm confused. Okay, let's just start from scratch over here. Okay. Negative on power supply to negative on ammeter. This cable is short. Maybe that's why I wasn't using it. Okay. Positive on ammeter goes to resistor. So I'm going to go resistor negative and then positive because that goes into the capacitor. Okay. Then power supply positive go negative on the capacitor. What? This doesn't. No, because I'm stupid. That's why it doesn't make sense. Okay. Nope, nope, nope. Whoever made this chart should be fired. Okay. Multimeter negative goes to capacitor negative. So let me grab, I don't think it was this. It must have been this. No, it was not that. It was this. Okay. Multimeter negative, cap negative. Okay. Multimeter, no, that goes to cap positive. Multimeter negative goes to power supply negative. Okay. Let me do this. Negatives are joined no matter what. And cap negative. I don't like it. Why is this so weird? Let's do this. And then everybody's favorite activity. Hold on. Cutting off the safety shield. Aw, yeah. Who needs safety? Anyway, back to my fumbling. Yeah, I saw the ping about hard sector stuff. I will have to look at that later. Okay. Multimeter negative to power supply negative. Multimeter to, no, power voltmeter positive. Okay. Goes to cap negative. Okay. Just one of those weird things to set up. And the cable is really short. Somehow I made every single one of my cables exactly too short to be able to just reach the bench. Wait, this one can. Which means this one needs to dangle. Voltmeter negative to negative. Okay. That's the wrong one. Negative to negative. Positive here to this. That one's nice and long. And then negative here to there. Okay. I think I got it figured out. Oh my gosh. so stupid. Okay. Let me route through this once mentally so that I know I have it right. Plug in cap. Okay. Positive side of cap is connected to resistor. Resistor is connected to positive side of multimeter. Okay. Negative side of cap is connected to... Dude, I swear I can't make this up. Okay. It's my fault. I have screwed this up in the exact same way twice now. This is my graphic for how to set this up. I keep mistaking the power supply for the voltmeter or the ammeter because it's on the right and my ammeter is on the right. My power supply is on the left. I keep getting them backwards. It's driving me crazy. Okay, power supply. Resistor, negative. Goes. That. Done. Okay. Yes, change the graphics, but I'm not doing that right now. That's not happening. Okay. Yes, it's my own image. I know. This is the one that I made for the video that was supposed to be, like, unit agnostic, not represent a new one. And yes, I like everyone telling me draw a new one, obviously. Okay. Positive goes to resistor, goes to power supply positive. Okay, power supply negative goes to ammeter negative. Okay, ammeter negative goes to capacitor negative. Okay. Check this one more time before I start crying. Resistor, positive, capacitor. Okay, resistor, negative, goes to positive power supply. Check. Okay. Cap, negative, goes straight to ammeter, negative. Ammeter, negative, goes to power supply, negative. Okay, we are ready to reform. Oh my gosh. Okay. Things, stuff, do, complicated. Here, I need cap reforming. I need a, not to use the dasher keyboard. Reform V2. Okay. We open the website. Now I can configure capacitor reforming. Okay. Coder Joe, thank you for the 100 bits. Sorry about the deck talk, not reading it out. I do not know why it has stopped working. It is something to do with the internet, maybe. I don't know. Okay. To start out, just to test, big cap, positive, negative. Let's just see what happens. Okay, going over to the software. Again, not typing with the dasher. Going to 5 volts. Here, 220. Current minimum, 3 milliamp. Current maximum, 5 milliamp. Log name is logged. Okay, and go. And it didn't work because nothing is turned on. So that's fair. Let's turn on the 50 volt 6633 and the 34 401A. Okay. Target voltage, 5 volts, 220 ohm resistor, 3 milliamp, 5 milliamp, and this cap reform. But then I have to go into here, and I have to refresh. And okay, that looks like that's good. And go. And it still didn't work. File not found error. We're just going to hope that that does not matter. Back to setup. 5, 220, 3, 5, go. Why? Am I getting the stupid again? Why is it complaining about log.csv? Yeah, the universe really does hate me today. That's the correct power supply. That's the correct ammeter. Go. And then I literally changed nothing and it started working. Okay, there we go. That's working correctly. You guys should be seeing a chart in a moment. And there we go. Okay, all good and ready now. Alrighty. So we don't actually want to reform this cap at the moment. So we're going to stop the reform, go back to setup. All right, because this is not the cap we have from this machine. Okay. Blah. All right, I have the cap reforming setup going back over here. We're going to start out with this little tiny cap here. Slugs are, again, perfectly sized for banana jacks. It's not going to be true for all of these this time. So this is a 6300 microfarad 20 volt DC cap. So this one's going to be really easy. I am just going to start the cap reforming process here. I'm going to go with we'll go with 3 milliamps minimum and a 5 milliamp maximum. I'm going to call this 39 20 volt, and we're going to go. There we are. So the cap reforming is now happening, and well, yeah, that's pretty much it. That is going fast. Holy moly. Wow. Okay. So I'm going to remove the overlay here. The cap reforming, yeah, the higher current limit that I gave it this time was very fast for this cap. So that's it. It's done. So that took a minute. Zero time at all. So I'm just going to go ahead and run that again. Back to setup. 20, 3 milliamp, 5 milliamp, and go. We're going to use the default log because I don't actually need to save this. This should go even faster this time. Yeah, we're already up to 7, 8, 9, 9.5, 10. Yeah, okay. So yeah, high current is fast when you're using that. This is much higher than I would normally do, but pushing me to do it this fast when we were doing... I thought I was going to beep sooner. Of course. When I'm talking, kept waiting. Anyway, Socket was pushing me to do these faster. So I guess there, yeah, that one's fine now. Okay. Next cap. All right, so we'll pull this one because it's done and ready to go. And then we'll do this one. This one's also 20 volt. Make sure I get these correctly installed. Boom. This one is double the capacitance of the last one. Did I drain it or is it spicy? You know what? It might be drained or spicy. Hold on. That's really important on this one. It was at 2 volts. We're just letting it bleed now. Okay, it's at 2 volts still. Good call, Jason. Or Paul Guy, sorry. Verified the actual capacitance. We haven't. We can do that after the fact. All right, that's 0.2 volts. Well, it's still pulling current. 0.1. And there we go. Now we're done. Down to 0 volts. Let's keep these over here. All right, now the next one. Positive, negative. Okay, that one is currently at 0 volts dead there. Okay. All right, I'm going to set up the next one. This is 20 volt to 20 resistor there. We'll go the same. 3 amps minimum, 5 amp maximum, 60, 39, 20 V tall, and there we go. So fast. It's going to be done in less than a minute. This is just bananas. Okay, maybe not less than a minute, but it's going way faster. We're slowing this down a lot on the big boy. Or, well, maybe not a lot. It might just go slow on the big one. Thought about bulk preforming caps in parallel. So I could have with these two, but usually we don't have the same voltage on them. And there we are. That one was also very, very fast. Should be good. I'm gonna let it discharge, and then we will move on to the beast. All right, we're down to 3 volts. With current ranges this high, we're not even like using the resistor part of this setup. All right, we're sub 1 volt. I'm gonna let that, oh, I might as well just let it finish because it will go fully. It's taking, you know, roughly twice as long as the other one to discharge, shockingly. And come on, give me less than 0.1 volts. Close enough. There we go. All right, now for the final one here. We're going to plug this in there, this in there. We're going to clip, crunch, and then boom. All right, so this is the Sangamo. It is a 40 volt DC cap here. 24,000 microfarads, so that is like way more. Actually, that's double the last one, isn't it? It's not that much more. But at a much higher voltage. This one's going to take a whole lot longer. So 40 volt, 24,000. Let's get that one set up. Oh, you guys couldn't see that. Here, I clipped it on. They're clips. That's clip. Oh wait, no, twice. There you go, because there's 2 posts. There you go. Okay. So, kill reform, back to setup. Okay, so this one is 40 volts, resistor still 220. We're going to leave it at 3 milliamps. Do 5 milliamp maximum. Log this as 6039 dash 40 volt dash big. All right, and go. All right, as long as the current starts dropping eventually, then we know the cap's not shorted. So it's pretty simple to do, or to check that at the same time as this. All right, we're not going to let this one be because it's going to take a lot longer than the other one. And for the benefit of stream watchers, here is the overlay for this one. Yeah, you can see how now it's really starting to settle in. That's what a bigger cap does. How's the Nova going? Nova is cranky pants, but we're doing something else. Car purchase from vending machine. Thunder, oh gosh. All right. While that other cap is reforming, we need to solve a problem, and that problem is this capacitor. So this is a 660 volt AC cap that is 2.2 or 2.0 microfarads. This might be some kind of oil-filled paper cap. I'm not 100% sure, but there is a way to potentially test this, and it is one of these. So this is a Heathkit condenser checker. Now, this can output up to 450 volts. And I don't know what this does. Maybe it's like tuning or something. I've never actually used this. We're going to pop the back off of this really quick, make sure it itself does be able to, that doesn't feel right. We should be able to, ooh, that's weird looking. We should be able to use this to reform this up to at least 450 volts. If it needs reforming, at the very least, we can look at the pretty magic eye, whatever thing on there, and see what it looks like. First though, let's pop off the back so we can see what it looks like inside. Because this device heralds from the Stone Age, uses flatheads screws. Want to be careful. I don't want to gouge it up. It has that delightful crinkle paint that was so prominent in like the 40s. I don't know when this came out. I don't think it would have been the 40s. But yeah, I don't want to damage that because it looks pretty. I also don't know that these cable things are going to actually loosen the back. No. They're screws somewhere else? How do you dismantle this? You don't go through the front, do you? Ooh. Okay. You kind of do. Got it. Okay. Complicated. All right, we got a transformer. We got one of them things that that one guy that was here probably would have liked to see. Down here we have, this thing's been worked on. This either already works or will never work again. Those are feeling like modern caps. A lot of this stuff actually looks kind of modern. Well, that's interesting. Guess we see what happens. Yeah, I was thinking the power cable looked suspiciously, melted. And corroded. Ooh. I don't like that. Okay then. Just put some tape over it. Okay. What about the green bits that are flaking out? Oh yeah, it's definitely got into a wire. Okay, yep. Power cables are like $1. We're not. Look at this nice power cable. It's got grounded plugs. I got a label because I was using it. Boop. It was decapitated. All right. I'm gonna strip this bag. I don't know. Did they put a fuse in line? What's on the yellow shrink tube? Ah, there we go. Okay. I'm gonna cut that open. I want to see what that is. There is a fuse in, you know, somebody actually did a pretty good thing. The fuse is, it appears to still be intact. So it was probably never powered after whatever happened. All right. Watch out for that tube. I'm going to kill it. All right, all right. Yep. That's not keyed. Why wasn't it? Okay, it is keyed. There's a plastic peg in the center. Oh my gosh, I was horrified there because the pin's all the way around. Oh my gosh. That one's probably fine. I'm resting on the socket, kinda. I can do it this way. Actually, there. Okay. So weird, it's been back. Glad I opened this because I hadn't the power cable. That would have been a fun surprise. I would if I could, Vorpal Sword. That's not really I can totally control. Original Heathkit power cords here. Oh, see, I see how it is now. The tester itself is free. You want the power cable, though. With this having been modified at some point, It's hard to say if it will ever work again now, because I don't have a valid reference point to debug from if it has issues. Oh, this one's going to be a nightmare. Lugged straight to the chassis. All right, Heathkit 1, Metcal 0. That's the first thing I think I'm ever giving up on using the Metcal for. I think that's don't worry. There's always a bigger soldering iron. Although, I don't want my hands near this when I'm using this one. So let me find the pliers to pull that cable out of there. Okay, how can I do this? Why does it have to be so deep in there? We make sure it actually gets warm. There we go. Okay. Solder doesn't seem to want to stick to the tip though, but whatever. This one is more difficult to use. I like how it glows though. That's cool. Maybe there's an easier way. Oh, suddenly I don't have to heat up the entire chassis anymore. Wow, that was way easier. Who would have guessed? I just removed the bolt that was holding it to the chassis. Yeah, I probably should have done that from the beginning. Now I have the insane iron hot. Cool. I'm just gonna go put that somewhere else. All right, now I can feed this through, untie it, and replace it. It's a shame that failed, because again, I feel like they did a fairly reasonable job on this. Do my own tie here for strain relief, because that is a good idea. Not easy. There we go. That'll work. All right. It may not even be copper-coated aluminum. Accidentally picked a decent power cable. All right. Green to lug. That one's easy. Let's just do that first. This may not be necessary or this thing. A lot of stuff like this was never grounded to begin with. All right. White goes to this side. And black goes to the little baby fuse, but that's their shrink tube. Because that was a good idea. Yeah, Heathkit capacitor tester. What do you mean $130? That's not gonna work. The cable, oh yeah. There we kind of go. Okay, I'm gonna put more solder on that. A little bit on there, wake it up. Oh, because it was a nice one. Now I see what you're saying, yeah. I think stream delay didn't help there. Okay. And then I used the heat gun on the shrink tubing to collapse it. And it worked really well, and it was applauded how I did it, because it was so correct and the right way, and they all learned how to be better electrical engineers because of it. And it was good, and everything was great, and nobody complained about anything, because it was all done the right way. And it worked out, and it was clean, and it looked good too, because I did it the correct way, and that made it nice. And I didn't, my shrink tubing doesn't go as small. This is probably like a 2-to-1, like a 3-to-1 I was on there. Oh well, close enough. All right, there we go. There's that. I got to put the screw back in. I think we're good. Proof of your nephew's writing good letters to ease. Oh my gosh, that was one of the mount points for the transformer too. Jeez. Why? It makes it so much more complicated. Heathkit, you could have spared an extra nickel for one more screw. Come on. There we go. Self-insulating screw. All right. That's good. That one's 100% perfect. No one can argue otherwise. Hold on, we can make this even better. Self-stealing stem bolt. Now, you know, you're saying that as a joke, but it's making me think this would be a good use for one of the self-shrink tubes. That would actually be kind of nice. Okay, this is not working. We getting into vacuum tube gear? Unwillingly, yes, and unknowingly. You know, let's be real. It's not going to hit anything anyway. That's probably fine. Okay. I think we're good. I think that's it. Oh my gosh, I only got 5 minutes left. That cap is not even close to done. One nice thing about reforming caps, though, is, I mean, you can just pause and resume it later. You almost don't lose any time because you've already reformed that part. It's gonna just blow through it again super fast. Okay, gotta put that one tube back in. I do know what's happening in the reform process to make mine. The power supply is going constant because the voltage was getting up so high that it was just doing that. So that's what happened. We're pretty close to tripping over to that. We literally just hit it as I was saying that. It's now in constant current mode. Or it's about to be. It's real close. F, what do you mean F? I think we're okay. Back, okay. Why wearing a glove? I don't want to get finger oils on the bulb, the tube. If it gets really hot, that can be a problem and cause hot spots on it. All right, I think we're ready. All right, after a mini detour of replacing the power cable, because the original one had like a soldering iron to hit it, and discovering this thing's already been recapped, I'm going to plug it in to see if it works. I don't know if it does, so this is cool. It has a fuse in it, so if it blows that, but here we go. How do you even turn it off? Like AC off. So I probably want it... okay, there to start. Okay. So yeah, I don't know what any of this does. I'm guessing that's as off as I can get. So let's find out what happens. Okay, it didn't explode. I like it when that happens. So if I click, Click. Click. Okay. I got no clue. Oh, we got Magic Eye. Hold on, that's pretty sweet. Look at it, green. Okay. All right, so that is actually working. No idea what the power factor thing does. Looks like maybe paper and mica is where we want that. Okay. Okay, I think we might be in the range. I don't know if you guys can see this. But that is the match, and I can get it close. So that's working. Matches the cap to the cap capacitance, and if it matches, I lights up. Okay. So here's what we're going to do. I'm going to get the fluke. I'm going to plug it into the front here, and I'm going to measure the voltage coming out of this thing in AC, because I'm pretty sure that's what it'll be. Okay, we're at 4. There we go, 4 volts AC. 45. 62. 60. 20 to 1000. Swap it over to lead. I don't know that it's actually working. I mean, the Magic Eye does something, so hopefully. Okay, so 25. I don't know. 150. It may not be happy because there's no load, but it is doing something. So, okay. I'm going to turn. I'm going to set it to normal here. Okay. I think this is going to do something. I don't know what the rest of that does, but I'm going to set this to leakage. And then I'm going to cycle through this, and we get nothing. Okay. I'm going to connect the cap. This has not been opened yet. It should, in theory, be impossible for me to overvolt this thing, so I'm not super concerned about using this. I do need to chop off the stupid safety things. So I'm going to do that here. And I say stupid, but this is maybe the one time I actually wouldn't mind having them. Where shall we read the chat? Are we hearing Discord? What does it matter? Had freeze? I don't know what about chat? I'm not seeing anything I need to read. It's seeing AC. Unless you're saying, oh, leakage would be DC. Ooh, you're right there. Wait a minute. Normal. Okay. So 20 to... Can I adjust it with this or something? Because if it's only 60 volts AC, that's not going to do a whole lot for us. Hmm. Yeah, we won't do that. That will be bad news. Although being AC, I mean, actually, it kind of should do it. Yeah, let's just try this really quick. So, leakage, volt. 25. Okay. That's DC. Definitely. Okay. So it still had a DC. Weird. Okay. AC. Overload. Nope, 60. We can only go to 60 volts AC? Really? Well, it's still going to be better than nothing. Sleepy, thank you for the 100 bits. Sorry the deck talk didn't work. I have no idea why it's not working. What? Oh, okay, there we go. Let's not do that yet, because I don't want them to short. Okay. These don't want to go together, but they're together. I don't care. $60 really going to be it for AC, though? That kind of sucks. Extra stream. We're basically just going to find out what this is like, and then we're ending. So, all right. I'm going to put this here. I'll put this here. Gonna plug this in. All right, we now have a load. Okay. So we have our magic eye. All right. So the capacitance is 2 microfarad. I don't know what the units are on this. So that's cool because they're not really labeled. I'm going to guess that it's 2. So, or that it's microfarad, although it really doesn't make sense. Cap test 1 to 50. So if it's 1 to 50, it might be, I mean, I don't know, man. Let's just, 1 unit equal 1 microfarad, but there's multiple scales. Outside is also R, which, I don't know. Does it measure resistors? I don't know, man. I'm just going to crank the voltage. I don't like that the voltage did not go up. That should be 5. I don't know what power factor is going to be. Nothing's changing. I'm not thrilled about continuing. Okay, it's not shorted. That's a resistance measurement, and it's showing like 4 mega ohms. Yeah, I think I need to actually read a manual on this. So I'm not. Being a Heathkit, there's probably a manual for this somewhere. I do not want to have this explode on me. So just going to leave that be. The manual, all right, yeah, but I'm going to have to actually read that. I'm not going to just rifle through it and then hope for the best here. I know how the magic tube works. That part, I get that. I'm not concerned about that. I'm concerned about the parts where literally nothing has a unit anywhere on this thing. Okay? 0 units, bolts right here. Okay? Nowhere. We got res and we got C. I don't know what res is. It's not like this thing's going to be used for measuring resistors. So I don't know what the deal is with that. The power factor thing over here, not thrilled about that. So yeah, I need to understand this more before I continue. It is for resistors. That's super weird. Why is it a condenser checker and then it has a resistor thing built in? So yeah, I need to know more about this. We're gonna just not continue on that. Anyway, tomorrow, I mean, oh, that's so annoying. It's at 30 volts. It's 75% done on the cap. How long would it take? I can actually predict this. One moment. Hold on. We may end a stream here. So to go from 20 volts here approximately to 30 volts here, 205 to 150. So it would take 15 more minutes, maybe 10 more minutes to just let the cap finish. Right now, we're at a slope down, so it might be more like 15. I don't know. Cap can just keep going after stream. I mean, I don't hang around the office. I have been live for 4 hours. I've been here already working on stuff, and I'm going to go home and I'm going to edit. I don't live in the office, so I leave here. But yeah, watch it after stream, exactly. Discord, any of that chat will disappear after. If you could put it in Discord, I would appreciate that. So I will probably watch. Yeah, no. Apparently they're emulator. So list 4 ranges, all ancient. Yeah, that should be microfarad. I need to know more. I'm going to be happy with it. I think I get the idea, but I'm not thrilled. There is no microNOVA there. Okay. We are so I'm kind of just waiting on third time. It's so close. I really just want to wait and let the cap finish. It might be at a point where I don't know what the voltage at that part of the on things like this will have it to like or anything, but not this one. That would be too nice. See, I think a diode, and then there's a bunch of stuff there. No, it's not in the copper anywhere on this. If it was like a 25-volt rail or something, then we could call it because it will be good. We're just over reforming it at this point. Oh, that's right. I have both overlays active for you guys. I'm just watching a full-scale chart right now. Play Hydro Thunder while it finishes. It will take so long to get the cabinets to even turn on that it would almost be done. Well, I mean, literally walk over and flip a switch, but it's not worth it. I don't know. It seems like the steps are maybe we're, you know, ooh, actually, this is an interesting point. I almost really want to let this finish. Dang it. Chart again here now. Can you guys see the mouse cursor? Let me double check if that's actually being captured or not. Let me try and enable that show cursor. Okay. So if we look over here, we can see how it is like an X, but have a knee. So that's interesting, but it ramps out so that it curves, but I feel like we're reaching another knee here around 30 volts because we had pretty steady, and now the steps are about twice as long. Now we lost it all in the rendering here. It's just a problem with the JS thing. We're now reforming voltages that have this thing. That would make sense to explain what. So I hadn't considered that all the way to rated voltage would take way longer than we need, be pointless, just consume more electrolyte. Huh. Interesting. Yeah, you know, I think we're going to call it. Should just stop streaming because you guys can't even hear it anyway. So we're going to end the stream. That's happening. We're done now. Okay, because it's apparently not even worth doing. Okay, so I'm going to kill this, run the outro. In a second, I got to reconnect to the server. Okay. Oh, great. I have been recording for a while. Drat. Yep, that was a lot of nothing on the condenser tester. About half of that was wasted. Oh, well. All right. Okay, ending stream because it's not working anyway. All right, well, thank you all for being here. We're going to continue on the floppy drive unit tomorrow because we have no other concept of what the problem is with the microNOVA. Just hoping that getting it to try and access some kind of like bootable media will make it work. We do have to figure out, I'm gonna go look at the motherboard on the floppy drives one more time over here. Is there a jumper section on it? Because we need to figure out how to set the IDs for the floppy drives because I have no idea. I am not seeing any jumpers on here. I'm just going to take a big old picture of this. I probably already have, but I'm going to take another one, and I will end up putting that on the wiki later. Hopefully jumpers can be found or something. I don't know. Gosh, that's a big PCB. Probably going to need to take that under better lighting later. Yeah, because we need to figure out how to set... Oh, that was terrible. That's truly awful. Need to figure out how to set the jumpers for the address for the device loader so that it knows what to try and boot from. So that'll be fun. But hopefully, because I have a boot floppy, it actually tries to boot from the floppy. And it doesn't try to boot from the hard drive. But if it does try to boot from the hard drive, I'm going to have to tell it to try and boot from the floppies instead, which will be fun. So, yep. But anyway... Okay, we're gonna call it there. If you all enjoyed the stream, you may want to follow to be notified when I go live again next, which is tomorrow. If you want to help support the stream, you can find me on Patreon or get a shirt like this one. Yours won't come with a big splotch of dust that I didn't notice until just now. But that's gonna be it for now, and I will see you all next time.